I'm Gina Neff. I'm an associate professor here at the Oxford Internet Institute, and I would like to welcome all of you to this year's Bellwether Lecture. The OII Bellwether Lectures bring world-leading intellectuals to Oxford to lecture on the social implications of the internet, its role in shaping our economic and political and social futures. The series is named after the Middle English term for a castrated ram with a bell around its neck, which would lead the flock of sheep. Happily, this translates into the modern idiom as an entity that serves to create or influence trends and predict future events, not all of us following our speaker around for the rest of the evening. The Oxford New American Dictionary quotes an equally vivid, if slightly more relevant, example from digital economy management guru Tom Peters, writing in Fast Company, quote, "Revolutionaries, take note. Charles Darwin said when species change too quickly, there will be little chance for their survival, but very few will become bellwethers and redefine the world." Now, if there's a single scholar whose work meets these criteria of bellwether, it must be tonight's speaker, Professor Paul Dourish, Chancellor's Professor of Informatics and Associate Dean for Research in the Donald Bren School of Information and Computer Sciences at the University of California, Irvine. He has courtesy appointments in both computer science and anthropology. Professor Dourish's research lies at the intersection of these disciplines and more, combining science and technology studies, social informatics, human-computer interaction. As an example of the interdisciplinary approach to his work, his 2004 book, Where the Action Is, The Foundations of Embodied Interaction, brings all of these together with philosophy too. And it's changed the way in which we think about the phenomenology and practice of computing. The book now has over 4,000 citations. In addition to this, his achievements have been widely recognized in multiple fields. He has been named Fellow of the Association for Computing Machinery, a Fellow of the British Computer Society, a member of Sig Chi Academy, and a recipient of the AMIA Diana Forsyth Award and the Computer-Supported Cooperative Work Lasting Impact Award, certainly a bellwether. What makes his research of particularly interest to our community is that his career-long commitment has been to thinking about information technologies as sites of social and cultural production, and also his commitment to inform the practices of making those same technologies. Before the University of California, he was a senior member of research staff in the computer science laboratory of Xerox PARC. He's also held research positions at Apple Computer and Xerox EuroPark. He holds a PhD in computer science from University College London, we shall forgive him for that, and a BSc in artificial intelligence and computer science from the University of Edinburgh. A final note on bellwethers before we welcome Professor Dourish to stage. He has the honor, the distinction, of having handed me my first conference rejection. When I was a doctoral student for the Doctoral Consortium of CSCW. Now, thankfully, this was not a bellwether for my career. Professor Dourish did so with grace and kindness and support, as much support as one can give in sending out rejection notices. But let us remember, from our past mistakes, let us remember that our words have impact and that those we do not accept today may use castrated rams in their introductions of us in the future. Please join me in welcoming Professor Paul Dourish.
Yes, there are many lessons in that for us all. My recollection is that we decided that you were already too advanced to need the doctoral consortium that year. But thank you very much for that introduction. It is a genuine pleasure to be here, which I guess means unlike those fake pleasures that I occasionally feign at other institutions. And an honor to be invited to deliver the Bellwether lecture, orchestrated RAMs notwithstanding. It did leave me wondering if I was to try to institute some similar thing in California, what a Californian equivalent would be, some hobbled surfer or disgraced plastic surgeon or something. I'm not entirely certain. I also need to say, because I always do this when I come to give a lecture anywhere, is it's always fascinating to see what notes are lying around. So I wish I were delivering a lecture on the Masons and the mysteries in 18th century drama, which unfortunately you all missed by a few days, but highly recommended. Okay, so what I want to, I was going to say, tell you about, but actually discuss with you tonight, because I'm looking forward to the opportunities for interaction, are some ideas that I've been playing with for the last several years, and that are the basis of a new book that just came out a few months ago, May, around what I've been terming the materialities of information. And so in the book, I sort of there's a part of the book that's more sort of analytic and theoretical, and a part that's more grounded in case studies. I'm going to sort of talk tonight about a couple of those case studies to try to sort of show you what kind of shape the project has. But obviously, before I do that, I have to sort of back up a little bit and talk about materialities, about materiality, and about the fact that my slides are not moving, which is a little disturbing. Okay, let's just, I've never had that happen before. Let's just do this, ding. And there we go. All right. So on the surface of it, perhaps not so much to the people in this room, sophisticated thinkers about the internet as you are, but on the surface of it, to talk about the materialities of information would seem like a somewhat sort of quixotic project, a strange effort, given that the sort of foundational rhetoric of the digital is the rhetoric of immateriality. When we think about digital information, when we think about the things that we do with digital information, we think about a displacement of atoms by bits in Nicholas Negroponte's terminology. We think of, when we get pictures like this, there are various things that we know about the world of digital information. One of them is that it is immaterial. The other is that it is blue. These photographs are always unquestionably, there's this particular shade of blue that somehow designates the digital realm. But even the translucence of this figure suggests a dissolving of materials. Now, we also know, of course, that digital systems are themselves all made up of material things, right? That the irony of the name, the Internet of Things, is that we already have an Internet of Things, and it's called the Internet, because what the Internet connects are things. But that's not really where I want to sort of take this. I'm going to be focused on a different kind of materiality. But so let's sort of start off by asking what it is that different disciplines might have to offer us if we want to think about the nature of the material in the digital and the digital in material. So we might start off, for instance, I realize I was going to say, I know the line I was going to say. I might start off, for instance, with material culture and the way that people in anthropology have thought of it. I'm going, maybe I should just make people guess on the basis of this photograph which discipline I'm starting off with. I don't know. Actually, I suspect this photograph is becoming dated. I'll tell you in a minute, and we'll see. But so from material culture, from anthropology, we have a number of people who have started to explore how it is that objects carry symbolic meaning and symbolic value for us. Yeah? And so, if the discipline of anthropology is largely about sort of like, thinking through that question of symbology and semiotics, a number of people since the 1980s have been concerned with the disappearance of the actual objects around which culture is organized within the discipline of anthropology and have attempted to recover those artifacts. And so, scholars in material culture have started to turn our attention towards the way in which different kinds of objects and artifacts operate within sort of larger symbolic fields. This is what, when I was starting this project, I sometimes called why iPods are cool and Zunes are not. This, for anybody, as another aside, one of the natural consequences of sort of faculty life, I say this now to the younger of you in the audience, is to be continually presented with one's own age. As one presents examples to students and discover that they've got no idea what on earth is going on. This image is going to be one of these for me very soon. So this, the logo of the Zune, Apple, or Microsoft's ill-fated, short-lived competitor to the iPod, a small music player, that somebody, at least one person in the world, felt strongly enough about to have this done. So the notion that digital objects, just like other objects, carry significance, express value, that they are objects around which affiliations are developed. That's one way we could start to think about the materialities of the digital. Maybe not just the digital artifacts that play music, but other kinds of digital things too. Or perhaps most obviously, we could look towards science studies, which since its inception has been deeply concerned with the way that material objects of different sorts and material practices play a highly significant role in the development of scientific knowledge. That to be able to make scientific claims, one not only has to construct an argument, but construct a network of supporting actors for whom that scientific statement makes sense, and those actors may well be, pieces of equipment so powerful that they cannot be wrong, right? And things that we could, things for which that lend legitimacy to the arguments through their sort of just through their massive presence or through the ways in which they exclude others. So from laboratory lab bench studies to studies of large-scale big science and enormous pieces of scientific infrastructure, colliders and so on, science studies has been concerned for a long time with a notion that material considerations underwrite even the apparently immaterial claims of technoscience. And perhaps the part of the science studies here that is maybe most familiar to those of us working in the digital are studies of infrastructure. And the kind of work associated with people like Lee Starr and Jeff Bowker and a number of others who have turned towards infrastructure and infrastructuring as a way to sort of bring an STS sensibility into conversation with the digital. And they sort of point to infrastructure as a relational fact, right? So infrastructure is to be understood not so much as something that lies hidden inherently, but rather as a stance that one can take towards objects or certain kinds of technologies when one simply relies upon them and uses them, and then the way we get caught short and caught up when suddenly they stop working, when we can't get connected to our Wi-Fi network, for example. I don't know how well people can read this. I always have to acknowledge this photograph was taken by Genevieve Bell somewhere in the northern part of South Australia, I suspect. This always raises a number of questions for me. One is that sign informational or a warning? I'm never terribly sure. And what you can't see, but I can see because I'm like right up here, is there's also these incredibly swerving tire tracks on the road. And I have no idea, again, whether that's the excitement of the impending access to the internet or merely a particularly juicy cane toad that had to be hit. But there's a story there. There's a story there. So infrastructural studies, again, have sort of like turned our attention towards a sort of a historically conditioned notion of access to infrastructures and the sort of the particular arrangements that allow infrastructures to seem like things upon which we can rely. And finally here, while I'm giving my list of things that I'm not talking about when I talk about materialities, we could look towards a sort of historical materialism, the concentrations of political and economic power that it takes to be able to produce our experiences of the digital, and that brings it to certain kinds of places and not necessarily others, through which people can achieve different kinds of ends. But again, with that sort of like historical kind of condition. Some of you may be familiar with this building. Actually, I won't tell you about this building now because I'm going to tell you more about this building towards the end of the talk. So, various people, various areas of inquiry with different kinds of notions of the material from which we might start to sort of like, feel our way towards an understanding of digital materialities. There's a different starting point that I want to have for the particular kind of work I want to talk about today. And for me, it comes a lot from a quote from Donald Schoen, who's a design educator at MIT, who speaks about design as a reflective conversation with materials. And when I read that phrase, the image that came to mind for me, that always comes to mind, is this one, right? It's the potter and the clay, and this notion that in working the clay and throwing a pot, the potter has some intent, design intent, artistic intent, some hope for what it is that the creation will be, which they then try to like work into the clay as it spins. And there are aspects of that design intent with which the clay will comply. There are ways in which the clay will take the shape that you want, will produce the kinds of effects that you want. There's other effects that you might hope to achieve that the clay will resist, that the clay will simply not be able to support because it becomes too thin to support its own weight, wherever it is, right? The ways that you have goals that can be achieved and goals that cannot. And then similarly, there are things that are beyond your immediate imagination or conception that you learn through your engagement with the clay, right? So when Schoen talks about a reflective conversation with materials, he's talking about design in a very generic sense. He doesn't simply mean this, but I find this a sort of a useful image. This notion that in crafting things, we are engaging with material forms that resist our will to an extent, that create opportunities, that suggest strategies, and that's the conversation. And when I encountered this work back in the late Middle Ages, when I encountered this work at first, I began to ask myself what were the materials with which we are engaged in doing digital design, right? I actually think this picture of design, this notion of a reflective conversation with materials, is one that is quite familiar to computer programmers, to system developers. It's even actually one, I think, that is quite familiar to all of us just as end users of computers, who recognize that as we try to fit our ideas, partial and amorphous and evolving as they are, into the computer systems that we have available, into particular kinds of programs, into particular kinds of databases, as I sort of try to map what I want to do into the terms that software gives me, I find, like the potter with the clay, that sometimes that works well and sometimes it doesn't. There are ways in which the materials of the digital come prefigured with certain kinds of ideas about how they should be used. And sometimes those work for me and sometimes they don't. But similarly, that in my engagement, I may sort of like discover other kinds of things. And so the focus at which I want to, or the level at which I want to focus my attention in thinking about these things are representational practices in the digital. When I want to talk about a reflective conversation with materials in the case of the digital, I don't mean my keyboard, which also occasionally resists my will. Or Keynote when I try to change slides, come to think of it. It's not that. It's sort of the representational level at which computer systems describe the world, describe objects in the world, describe themselves, make possibilities manifest within the technology. So the representation becomes the level at which we can start to answer sort of the question implied by Schoen's analysis of what is the material with which we're engaged, what bends to our will or resists it. By analogy, and so those of you who've worked in sort of human-computer interaction or cognitive psychology and other kinds of things, areas of that sort, might be familiar with things like this. I mean, there's a sort of familiar argument connected with number systems, right? So if number systems are representations of numbers, numbers are independent of the Indo-Arabic numeral system or the Roman numeral system or whatever. But when I ask you to multiply two numbers together, and I give them to you as sort of normal decimal numbers, it's pretty easy, right? We have a rote procedure that we teach 8-year-old kids or 7-year-old kids or whatever to do, and it's perfectly obvious and straightforward. But when I give you the same calculation but give it to you in Roman numerals, there is no rote mechanical procedure for multiplying those two numbers, right? You would have to translate them into decimal and then multiply them and then translate them back. So here we have a thing, an idea. It's not that it's become more difficult to multiply the numbers. We can multiply the numbers, but we can't manipulate the representations in the way we want in order to be able to produce our effects. So it's a representational commitment that then has these sort of material consequences for the kinds of things we can do. Roman numerals, as it turns out, really good for carving into the sides of buildings, not so good for doing advanced mathematics. Actually, I'm not terribly sure if they are really good for carving into the sides of buildings, but there certainly seems to be plenty of that going on. And some work along these lines has been done with respect to computer programs and computer programming as well. So there's an interesting line of research associated particularly actually with a group of people in the UK like Thomas Green and Marianne Petrie and Alan Blackwell at Cambridge, looking at what they called the cognitive dimensions of notations. So what they were studying was they're interested in sort of the psychology of programming. In particular, they were studying how people learn to write computer programs, and they started to catalog the kinds of errors that people make when creating and modifying computer programs as they learn, and they began to recognize in that cataloging that there are different kinds of errors that people make when they use different kinds of programming languages. And that those errors are, there's certain kinds of errors that are conceptual errors, there's certain kind of errors that are errors of sort of like, planning and broad understanding, but there are also a whole bunch of errors that are errors of execution, which are just that, that adding adding a parameter to a method is easier to do in some programming languages than it is in others. That some programming languages allow you, for instance, to do things, to specify things in different orders, but have it always be the same result, as opposed to ones where you have to do everything in exactly the right order. Or places where the character by character textual presentation of a computer program allows for certain kinds of slippages to be made without interfering with the program's complete behavior, and other ones where a single character is going to crash your your lander into Mars, which actually was one that was a comma versus a period. So they start to detail what they call the cognitive dimensions of notations, and there's a variety of these dimensions. Viscosity is one of them. I can't remember, fragility, other kinds of things. And this offers, I think, a sort of model for what some kind of understanding of materialities of digital representations might be, because I want to think about these as being material concerns. For all that this is on a screen rather than a piece of paper, I want to think about the kinds of manipulations that I have to make of a piece of text in order to produce a particular kind of effect in the computer as being material. They are constrained not only by the sort of conceptual structure of the problem, but also by its spatial characteristics, for example, right? The spatiality is pretty material. So these were sort of starting points, as I say. That the Schoen stuff I encountered actually in the cognitive dimensions years ago while I was still at Europark, I think. And this stuff was sort of brought back to me recently by a couple of cases that came up in some empirical work we'd been doing, and some in some more analytic work. And so what I want to do is take you through a couple of those cases. I'm going to spend more time on the empirical one, but I think we'll have enough time for both. So the two examples I want to tell you about, and the second one is network protocols. We'll get there in a while. But first, I want to talk about spreadsheets. And if you had told me that I was going to study spreadsheets or look at spreadsheets, I would have. I'm associate dean now, so there are more spreadsheets in my life than I had ever imagined. I hope this is a passing phase. But the spreadsheets that particularly came up for us, the thing that drew our attention to spreadsheets was some empirical work. And this was being done along with my colleagues Melissa Mesmanian, Janet Vertesi, Marissa Cohn, Matt Beets, and others. And we were engaged in an ethnographic project looking at sort of distributed science planning on the Cassini project at NASA. Now, we were doing this stuff a couple of years ago. Cassini's been in the press a lot lately. Certainly, if you were in Southern California, it was in the press a lot because it was run out from the Jet Propulsion Lab at Pasadena. But Cassini is a spacecraft that has been exploring the Saturn system since 2004 and just crashed deliberately into the planet just a couple 6 weeks ago or so. And so the end of Cassini was a big thing. And there's lots of things I can tell you about Cassini, but all I want to talk about today are spreadsheets. And these are not spreadsheets in the way in which you might normally think. They're not the sort of budget spreadsheets that I have to deal with in my capacity as associate dean. This is a very different kind of use of spreadsheets that we encountered. So here's the story. At Cassini one day, we are watching a meeting. And what's going on in this meeting is that the spacecraft's been running out of fuel for a long time. There's bits of it that are breaking off. You're going to be more careful about how you treat it. And so they have realized that on their next pass by Enceladus, I can't actually remember what it was, but just presume it was a flyby of Enceladus, they're not going to be able to do all the science that they had hoped they would be able to do. Part of the deal with Cassini is that all the different instruments that Cassini held were in the end bolted onto the spacecraft. That wasn't the original design, but they had their budget cut. So they responded by bolting the instruments onto the spacecraft. And that meant if your ultraviolet spectrometer is pointed this way, then your gravitational instrument is pointed the other way. And so if you need to take a gravitational reading, you need to tumble a spacecraft in space. And that takes energy and it takes fuel and things like that. So they're not going to be able to do as much science as they wanted. And so what they did was they had a big spreadsheet. I'll projected onto the screen at the front of the room, much like this one, and the spreadsheet had on it, this is not the spreadsheet, but you'll see why this is what the spreadsheet here in a second, and the spreadsheet had on it all the things that they had planned to do. And the meeting has a simple goal. By the end of the meeting, everything on the spreadsheet should be colored either red or green. Red if we're not going to do it, and green if we are. Great. So, get down to business, item number 1, beginning of the spreadsheet. Let's see, what does that look like? Oh, that's really important stuff. We should definitely do that if we possibly can. But we haven't seen everything else yet, so we're not necessarily ready to completely commit to green. But we could have a sort of greeny yellow would be okay for that. Then we get to the next one. It's like, oh, I don't like this one. I don't think we're going to be able to do this one. This one is like takes a lot of fuel. It's really complicated, and it won't generate enough papers in Nature. And so, literally, this is actually a metric that got used sometimes. Not in this particular meeting, but it did come up. So we're probably not going to do this one. But the person who can make the final decision is not in the room. So we can't absolutely color it red, but it's going to be pretty orangey. You can see where this goes, right? By the end of the meeting, there's a lot of tired people, a lot of fractious conversation, but not a lot of red or green. Instead, it looks something like, I don't know, like, that sort of charts from which you might decide what color you're going to paint your walls. It's sort of like a splash of all sorts of different kinds of things. Now, there's one reason to be interested in this, by the way, is you can't sort by color in a spreadsheet. You can group things by color, but you can't sort. I want to give a version. I talked about this research once while I was at Microsoft, and suddenly I was like going, oh, maybe it is possible, and someone's about to tell me I don't know how to use Excel very well. But anyway, but you can't sort, and I think that's actually important. I'm going to come back to that in a second. So this is one of the this is what sort of like started me looking at spreadsheets. Now it turns out there's not a whole hell of a lot of research on spreadsheets, given the. Yeah, okay, let's just stop and think about that for a second. Right. But yeah, I mean, you wouldn't necessarily expect there to be a lot of spreadsheets, except spreadsheets do a lot of stuff, right? There's largely two bodies of work on spreadsheets. The first is on spreadsheet errors. Let's think about a spreadsheet for a moment. A spreadsheet is basically a computer program written by somebody who doesn't know how to write computer programs and hasn't received any training or help. And so there's a lot of errors in spreadsheets, and there's a lot of spreadsheets in the world, and those spreadsheets do important things. Some of you might have tracked or seen the debate that arose in like economics journals over the fact that the published paper that provides the only academic foundation for austerity policies has an error in its spreadsheet and does not say what its own, does not actually point to the conclusion that its own authors drew. And it's only in analyzing the spreadsheet somebody realized, they had pulled down done a column, and they'd missed out a bunch of things at the bottom of the column, which were, the GDPs of several countries that completely confounded their results. So errors in spreadsheet matter, right? So there's a little study of errors in spreadsheets. The other interesting stuff I've found comes more from sort of organizational science, and it focuses on sort of spreadsheets as memory objects. This idea that when I have a process to do this year, the first thing I do is I go to last year's spreadsheet and I evacuate it of data, and then I keep the structure and I start again, right? So spreadsheets become records, and records become templates, and templates become processes, and that's another use of spreadsheets. But I would encourage people to study spreadsheets because we need more of it. However, we've got this other kind of thing, and I actually call these spreadsheet events. This is by analogy. German methodologist Schubert Knoblauch has this work he's done on what he calls PowerPoint events, like the ways that rooms are organized so that a person can stand in front of a screen, and the way that sort of talk is organized around what the PowerPoint can do. And so we're calling these sort of spreadsheet events. Moments when a group of people gather together in a room. It looks something like this. There's a person at the front. They've got a spreadsheet out, and we're going to like work through this stuff. And we've been in lots of these meetings, I think, program committee meetings, budget planning meetings, curricular development meetings, graduate student admission meetings, kind of have this property. And I want to ask, what is it about the structure of spreadsheets as a sort of representational tool that allows them to work in these settings. Certainly for the NASA people, it was working really well. Again, I'll come back to some of the reasons of why. But I want to sort of think about what it is in the spreadsheet as a representational tool that allows it to work that way. In the book, I go through a variety of different things. I'm not going to talk about all of them today. I'm just really going to talk about this first one, which is, of course, the primary one, or the major one, which is the grid. And here's the thing. Here's my sort of condensed snippet for this. Spreadsheets are never blank. They're only empty. When you create a new spreadsheet, it's not a blank spreadsheet. It's an empty spreadsheet. It already has a structure waiting for you to fill it up. And that structure is the grid, a two-dimensional grid. Maybe tabs and sheets give you sort of 2.5 dimensions, but basically a two-dimensional grid. And that matters in a sort of variety of ways, right? Because the very first thing that you put into the spreadsheet begins to commit you to a particular kind of organization of the data. The first choice you have to make is, what is the unit that I would like to map onto a cell? What is the thing that I want to be able to sort of manipulate here? What are the kinds of groupings of those that I might need, right? Because remember, on a spreadsheet, I can select a cell, I can select a column, I can select a row, I can sweep out a little region, but I can't group things into sort of non-contiguous areas, and I can't have a sort of weird, wacky shape. And so that decision that I make right at the very beginning, where I have to decide whether my object of attention is going to be the contents of a cell or a group of cells or a row and so forth, those sort of really matter, partly because there's no refactoring going on, right? It's not like I can come back later and change my mind and say that thing that I thought was going to be a row actually needs to be broken out to be 2 rows and a column. And there just aren't sort of tools available for us to do that. And in fact, that's, of course, is exactly why we get this sort of spreadsheet as memory object thing, is where we don't want to reconsider the decisions. We want things to be the way they were. So one of the things that spreadsheet offers to us then is a granularity to data. It's committed to a particular kind of granular arrangement. The second thing that the grid does in these meetings is that it anticipates. That is, it shows me what roughly is going to happen. I think about those meetings that I've been in. I think about the NASA meeting. I think about those examples, graduate student admissions, papers, deciding whose presentation should be part of a doctoral colloquium in 1990, whatever year it was, 2006, I think. And there's a spreadsheet where you go, okay, we consider row 1, then we go into row 2, and maybe we bounce down and go to row 15 and go up from the bottom for a bit. But the spreadsheet is a tool that allows us all, as we look at it, to decide roughly or to know roughly what's going to happen and how the discussion is going to go. Because again, each column has a sort of similar kind of characteristic, or each row has a similar kind of characteristic depending on how we've organized the spreadsheet. And the very idea that the kinds of things that get done once will be done again is itself a sort of anticipatory structure that allows us to organize our activities. I get to hear how people are handling other cases, and I get to figure out how it is that I want to do it, because the spreadsheet lays it all out for me and shows me what all is there in a way that allows me to anticipate what's happening next by analogy to what's going on just now. Similarly, the spreadsheet, that's why it actually matters what things get, how things get represented, and for instance, the fact that I can't sort by color begins to matter. I think it's kind of interesting, right? Suppose we go back to that case of a bunch of people trying to make decisions about a set of, the science they wanted to do. This is a bunch of, these guys are astrophysicists, right? These guys work by numbers. It is odd to me that they did not choose to assign everything a score from 1 to 10 and then just sort it and draw a line, right? They could have done that, but they didn't. And I actually think the fact that they couldn't sort by color matters and was an intentional choice. I have more reasons for saying this than I have disclosed, but it's like, but just given the way the organization works, in an organization not just driven by number, the idea that they use color seems signal to me. And what's important here is that certain things are manipulable within the frame of the spreadsheet and certain are not. I can't sort by color. I can't search by color. I can't compare two colors to see which one's more green, or to have the computer tell me which one's more green. These are all things that, in this particular case, are left in the domain of the social rather than being moved into the domain of the technical. The technical, interestingly, is providing an infrastructure that allows things to remain in the social. Right? Color is essentially an infrastructure that allows decisions to be recorded, but not turned into numerical scores in this particular case. The other thing that's, and by the way, before anyone says it, this is not actually a spreadsheet, but I was running out of photographs at some point. The other thing that spreadsheets do that is important, or the grid does, that turns out to be important in these kinds of spreadsheet events, at least in the specific cases we were looking at NASA, is that it aligns the information but keeps it separate. So here's the background. In that meeting, as I said, everybody had science that they wanted to get done, that they'd planned to do, and that now they're having to decide whether they can still support. And that science, by and large, the way this project worked, there were like 17 different instrument teams of scientists working all over the world who were concerned with particular kinds of instruments, particular kinds of scientific measurements, particular kinds of data. And each team had put forward the science they wanted to do. And of course, like I was telling you, right, all the instruments on the spacecraft, science means having my instrument pointed in the right direction at the right time for the right duration. And so the deal here then for them is that it's a kind of fractious thing. If you get your science done, it might stop me from getting my science done because your instrument is on the opposite side of the spacecraft from mine. If you get your work done, it might mean that I don't get my work done because your instrument operates really slowly, and so you're going to require more time, and that means I will have less. But it's sort of important for them that everybody gets to see what everybody is doing, and everybody gets to see. Janet has a book coming out soon on sort of relationships between her previous field site, which was the Mars rover team, and Cassini. And one of the fascinating things that happens in between these two is that at the Mars rover team, they had a custom of, like, in their daily planning meetings, the last thing that happens in the meeting is they go around and everyone has to say, "I'm happy." You actually have to produce the words. In Cassini, the important thing is that everybody's equally unhappy. Cassini did not pretend that everybody was a happy camper. So these are contentious kinds of things. Now, when we put the spreadsheet together, and I've got my column, and you've got your column, and my column says what the ultraviolet spectrometer should be doing, and your column says what the gravitational instrument should be doing, we see that they're the same in form. We see that they're side by side, but they ain't smooshed into each other. They're preserved even as we color them red and move on. But there's a sort of symbolic demonstration of alignment, even just in the sort of spatial layout. And I think that does, again, matter for these guys. And one way we could think about how this sort of matters is by saying, well, what else could they be doing, you know? If they weren't projecting a spreadsheet at the front of the room, I mean, they could be projecting PowerPoint, right? Except to present PowerPoint is sort of like to present a decision that's already been made, right? That's what PowerPoint's used to do. It's not something that's sort of like revisable and debatable. I could use a word processor to because it's revisable. And I think we'll just ignore that one because I've already I've spent too much of my life manipulating tables in Microsoft Word, and I expect you guys have too. And they're certainly not going to do the kind of job for them. Although it's not as though their spreadsheets were doing advanced math, right? You could just write it up on a whiteboard. But one of the things about a whiteboard is it doesn't move around. One of the important things of the spreadsheet is that it communicates to outside the room. It comes into the room from somewhere else, being pre-prepared, and it flies out of the room again to be communicated to other people by email and so forth. We could keep our stuff in a database. The database one is, keep stuff in a database, but databases don't really give you this sort of versioning and checkpointing that you would want. This one's interesting, this last one, the online document. So let me go back to a previous photograph. No, where's it gone? That one. So you might ask yourself, why would they not use a Google Doc or something of that sort, right? I can do like Google Sheets or whatever the spreadsheet one is. What can we see in this photograph? We can see there's a spreadsheet at the front of the room. This is that somebody is, somebody's projecting, that everybody is somehow talking about. These guys have spreadsheets on their laptops too. It's maybe even the same spreadsheet, scrolled to a different area, or they might be different kind of spreadsheets. It's not entirely clear. But the possibility, but here's the thing. This is the only spreadsheet that matters in the room. And what matters about the spreadsheet is that only one person who's operating the laptop that's connected to the editor can change it. And nothing can change without everybody in the room seeing and witnessing it, because it can only change in one place. I'm not, I've got a copy of the spreadsheet here, I can look at something else perhaps, but if I make changes in my copy, it ain't doing nothing. And so nothing can change on the spreadsheet without everybody seeing, and only one person can make a change dependent on the conversation in the room. And that's not true in a Google Doc. That's the whole point of the Google Doc, is that other people can be manipulating things at the same time. And so that very idea of the centralizing power of the artifact here, and the fact that, so it's like, ways in which online spreadsheets are not like Excel running on a laptop, right? There's, again, this is the sort of materiality of sort of, what's the word I'm looking for? I don't know. Multiplication is not really the word I'm looking for, but concentration, if you will, right? How things get concentrated in one place versus spread out across multiple ones. So things about malleability, things about transportability, things about singularness. Things about identity conditions on objects. These are the things that start to distinguish for us the multiple different kinds of ways in which this group could have represented data in order to make it work for them, and the things that a spreadsheet representation is offering. And so so these are when I talk about the materialities of information, and I'd always talk not about the materiality of information, but materialities, these are the kinds of things that I want to draw attention to: fragility, transportability, granularity. These are the different kinds of material properties. I can't talk about material properties that are doing this. Material properties that digital things have. Okay, let me give you my second example, which is shorter, but I was telling some of the students this story yesterday. So I want to talk about network protocols. And again, I'm going to sort of preface that with a little bit of random history. So I did my PhD in a networking group, not because I'm a networking person by any means, but it just happened that way, which meant I ended up learning a lot more about networks than I ever possibly would have imagined that I would do, just basically so that I could keep up my end of conversations in the pub, because otherwise it was just not going to be any fun. And it was, and my PhD advisor told me this great story, which came from around the time of the standardization or fights over the standardization of the ATM networking protocols, asynchronous transfer mode, which is a sort of family of protocols or protocol technology that was at some time popular amongst sort of telephone companies, and that they imagined would eventually take over the world. And they were trying to decide, and so here's the thing. It's not actually a packet switch mechanism. It's a circuit switch mechanism, but it has nonetheless, like packets, little cells that you break the data up into. And the thing is, with the cell, as soon as you've decided you're going to do that, you have to say, well, what size are my cells going to be? And there were a range of options. And in particular, in the end, the two options that were being considered were cells that would be 64 bytes long and cells that would be 32 bytes long. Big cells, small cells. 64 is not very big, but nonetheless, that's it. And this is an ITU standard. ITU standards, by the way, are particularly weird. I don't know if anybody's started standardization processes. I talked to somebody who was part of the ITU thing. The members of an ITU standardization committee are not human beings, nor are they institutions. They are countries. ITU is a United Nations thing. And therefore, the only people who are allowed to speak are diplomats. By and large, finding a diplomat who knows anything about computer networking is a challenge. So there's a whole team of people who know about computer networking who advise the diplomat and tell him what to say. He's the little sock puppet. And so the meetings generally proceed by the fact that a diplomat says something that his engineers have told him to say, and then everybody leaves the room. And everybody has to consult, and then they come back in again, and another diplomat from another country says, no. And then they all leave again. Well, it's a funny way to have a conversation. Anyway, so the members of the standardization committee are countries, and they end up in this battle between two sets of countries. And they're essentially big countries and small countries. And here's the deal. When you send a signal down a wire, some part of it might bounces off the other end, unless you have echo cancellation on the wire. And so it would be coming back. And when it comes back, it begins to interfere with other parts of the signal that are already on the wire. And so the people who wanted the small packets were trying to minimize that. The small cells were trying to minimize that. And the reason is they were small countries. Their wires didn't get to be terribly long. Essentially, there was a fight between big countries, primarily led by the United States, and small countries, led by France, who were fighting about the size of ATM cells. And in the end, by the way, they went with 48 bytes in order, like Cassini, to make everyone equally unhappy. And since I don't know that anybody really does ATM networking anymore, so it doesn't really matter. But it was again one of these signal moments that starts to go, okay, now if I want to think about the materiality of the digital, I want to think about networks. I have to start thinking about the fact that that packets have length, not just a number of octets, but a number of kilometers, and that those lengths matter because they are related to the length of wires, literal pieces of wire, fiber optic cables, and the rest of it. And so I think we can sort of start to, think about the weights, if you like, of these kinds of digital objects. So here's the other example I like to use in this area, and this sort of thinks about the routing protocols, the routing information protocols at the heart of, at least of the early internet, right? You know the basic story here. There's a bunch of computers. They all want to they all have to share information about the topology of the network so that packets can make their way through the network, right? The routers that connect multiple networks together need to share information. And the early ARPANET had a protocol for doing this, whereby the routers or the imps would talk to each other every so often and say, what's up with you? What new kind of networks have you seen? Who are you connected to? And so this information would go around. And each computer would keep a table that said, oh, if you're trying to get to this kind of destination, this is where you should send it to because that's closer to the destination than I am. So what happens? Well, as the network gets bigger, those tables get bigger, and those tables get bigger faster than the network gets bigger. So every one, the number of nodes goes up, but the size of the tables goes up exponentially. Actually, not exponentially, but quadratically. But the other problem they're having is exchanging all the information now takes longer because there's more things that every router has to tell every other router because there's more other computers for them to talk about and other routers and networks for them to talk about. And it starts to take up more and more of the capacity of the network itself. It turns out the network has no space left for people to actually do networking because the network is talking to the network about the network, which isn't really in anybody's interest except perhaps a network engineer. So, so what you have developed over time is a variety, and you can see it, you can trace it through the evolution of the routing protocols from RIP to GGP to EGP to BGP, the various kinds of protocols, start to find alternative ways of encoding and representing the objects that networks network, so that they can better manage to share information without having to blow the network capacity up. And one of the strategies is to stop talking about networks. Instead of saying, if you want to get to that network, or this network from my network or your network, we're going to have to talk in terms of some other kind of entity. And the entity in which contemporary internet routing protocols operate are called ASEs, autonomous systems. The interesting thing about an autonomous system is it's an institutional entity. You're not an autonomous system, nor are you able to have an autonomous system number, and nor am I. But the University of Oxford does, and the ESRC does, and Lloyd's Bank does. And so we end up not with the internet being a network of networks, if you will, but instead the network being a network of institutions who have a whole variety of defined relationships to each other, contractual and otherwise. And they're actually the people being sort of like interconnected. So it's a sort of network of fiefdoms, and interconnectivity as the sort of like coin of the realm for these things has sort of disappeared. Network connectivity has disappeared. In fact, with sort of protocol, with standard policy routing now, it turns out if I'm over here and you're over there and we just plug our networks into each other, nothing's going to happen because the relationships with the autonomous systems are not defined to allow it to happen. So it's now routing from protocol from one place to another, or packet from one place to another, has become a sort of commercial operation rather than a one of topology, and that matters. And the point of this is it's been pushed down into the very representations in the network itself. It becomes impossible to talk about things outside of that framework, because BGP4 does not allow it. It just doesn't, that's not what it represents. What's represented there is that stuff. And that brings us back to this building that I put up at the beginning. And again, some of you in this particular audience, some people might know what this is. But 1 Wilshire is a building in downtown Los Angeles. It does not curiously stand at number 1 Wilshire Boulevard. It stands opposite the end of Wilshire Boulevard. I think its actual address is something like 326 South Grand. It's not even on Wilshire Boulevard, but it's near Wilshire Boulevard. And it's one of the largest internet packet exchanges so it's one of the 2 largest in the United States and one of the largest in the world. So 35 stories of server farm. You can hear the air conditioning even over the hum of Los Angeles downtown traffic from blocks away. But the important point is the 4th floor. I don't remember where I took this picture from. So, well, first thing is, the problem, you know what I really want? I want a picture of this with a cloud in the sky. It was really, it's like, I actually went back for days in the hope of like one day finding a picture of 1 Wilshire with a cloud in the sky, but Los Angeles was not cooperating. And also I can't remember how many floors I cut off, so which of these floors is the 4th floor? But the 4th floor is what they call the meet me room. It's the room where where the of the internet happens, right? It's where Verizon's network meets Covad's network, meets AT&T's network, meets Level 3's network, and the rest of it. There's very few people work in this building, as you might imagine, a few engineers, a few security people. But one of the very few people who do work in this building is NSA. They have a presence in the building. How big a presence, we don't know. Doing what, who knows? But they are there. And it matters to me, at least, because in the multiple years that I've been looking at this, have been unable so far to find a single internet route that goes from my house to anywhere that doesn't go through this building. You just like trace it out and you start to realize, oh yeah, that's going there too, and those guys also. And this building is like 40 miles from my house, so it's like there's a certain kind of like concentration here. But this is actually the point about this is it's been enabled by the network protocols themselves. The very kind of representations create the opportunity for something like one Wilshire. So let me just wrap this up very quickly then. Here's why do these things matter? Well, they matter in a couple of ways, right? I'm trying to sort of do as part of the broader project is sort of like find a way to talk about the social and cultural practices surrounding the digital in ways that take the digital seriously. And by taking the digital seriously, I mean actually trying to grapple with the the practical realities of the stuff that people do. Not to try to imagine the digital or digital life as a sort of like as a metaphor of, for instance, immateriality. Not to simply take it as a sort of launching off point for a different kind of analysis about the sort of displacement of one kind of object by another, but rather to take seriously the, what's really going on, such as things like autonomous systems and rather than networks at the heart of the internet. There's a couple of reasons for doing that. One of them is just simply a sort of ethnographic responsibility. I want to be able to use these terms the way that the people for whom they are terms of professional practice use them. I kind of think if I turn up and want to talk about algorithms with people, but I'm using the word algorithm not to refer to something completely different than what they think they mean by algorithms, I'm kind of not going to get anywhere. And that's what takes us to the second side, is it's also like if we want to engage with those audiences and we want to like practically affect change in the world, then strategically it's a good idea to be not necessarily buying into their frameworks and buying into everything that they're doing, but understanding the technology at a sufficient level to be able to sort of like have that conversation. And there's a sort of archaeological project to an extent involved in this as well, sort of trying to look at the specific materialities as a way of sort of recovering or reinserting these things into sort of their historical and geographical specificities. So in the book, I sort of go through this. I've given you mainly one example and a quick part of another example. The thing about the various kinds of cases that I've been trying to work through is that they sort of they reach out to different other disciplines. Right? So most of the spreadsheet stuff in conversation with organizational sociology, the network stuff is more in sort of like policy space and so forth. And they operate at radically different kinds of scales. And so there's a sort of experiment here to try to figure out at what kinds of scales this stuff can work. What kinds of disciplinary conversations do we want to convene? I'll skip the software studies part. I think the one thing that I would like you to sort of take away again is this idea of trying to sort of move past a notion of what I sometimes call brute materiality, just the fact of stuff and the fact that everything is stuff and stuff has to be somewhere and all those kinds of things, to beginning to try to tease apart specific kinds of materialities, to recognize that we are in our sort of like social and cultural practices engaged through the digital at different kinds of levels with different kinds of material properties, some of which impinge upon us at one time, and some of which impinge upon us at another, that offer themselves up in different kinds of ways, so that an analysis of granularity is different from an analysis of fragility or transparency or weight and heft and the rest of it. And trying to sort of like, create a different level of analysis for doing this. So I will stop there, and we do, I believe, have time for questions before wine. Thank you.
We have a microphone not for the room, but for the camera, for the audio that will be on the recording. So Jordan can help you with.
And if you are asking a question, you will be obviously on film, so please keep that in mind if you would like to ask a question.
There's one here.
Hi, I wanted to ask about the spreadsheet example. You talked about certain things are possible and certain things aren't possible on a spreadsheet, and certain things are easy and certain things are hard. But in the particular case of the spreadsheet, the decision not to allow sorting by color is a decision. I mean, someone actually had to decide that they were not going to put the resources in to do that. It could be possible to sort by color, by font, by type size, and these are all issues. And I think there's a broader question, which is one of the characteristics of software is that it's extremely malleable. And the versions of software that we see on our screens are manifestations of a set of decisions, and they're constraints that are set up by people, but the constraints are not the same constraints that we would work with if we were dealing with an engine or a piece of metal or a piece of wood, where the material itself is much more constraining. The software is not constraining. It's a set of decisions that are made by groups of individuals. So what do you think this characteristic of software does to your argument?
So yeah, I mean, broadly, that's correct. Let's sort of think it through a little bit for these particular people. One is they weren't software engineers, so for spreadsheet, Excel was not in any way malleable to them, except in the ways that it had been, scriptable in Visual Basic or whatever, right? It wasn't going to sorting by color was not something that they could extend the software to do. Although you're absolutely right that first, as I said, I was quite conscious when I talked at Microsoft that I could be wrong, and one could imagine it's not as though Excel is the only spreadsheet in the world, and one could certainly imagine those things. And one could imagine similarly that feature was added in, or would be added in some other version. God knows there's whole teams of people trying to think of all sorts of new things for spreadsheets to do in Redmond. So. But the interesting thing, I think, is that this was for them a sort of learned practice around something that was relatively stable. How consciously they had sort of evolved that practice, I'm not terribly sure. Now, you're right to, on the sort of to the first and probably second and third approximation too, that software is stuff that is in general more malleable than the other things that for which we normally turn to a materialist analysis, but not as much as we would like to believe, I think. So I'm fascinated by, for instance, there's all sorts of things I can do. I can take a computer program and I can change every character of that computer program, but there's all sorts of things that the computer program does that aren't even notated in the program, right? They happen in the gaps. They happen in the lines, the gaps in between the lines. They happen in the way the interpreter operates or compiler operates, and those are constraints upon me for sure. And they're not ones that are available for change. Similarly, there are all sorts of other kinds of constraints about the expectation of what a computer is going to be able to do for me, what capacities it has, and so forth, that I think matter for us. There's an example I use at the beginning of the book that of nuclear weapons testing, right? So we haven't blown anything up for a long time, but we still make new nuclear weapons, and we make them through simulation. We design them via simulation. And so one could argue that where once upon a time the primary material constraint upon weapons design was the availability of enriched uranium or plutonium, now the primary material constraint upon the development of nuclear weapons is the simulation capacity of the computer. The simulation techniques that we use, the sort of Monte Carlo techniques and the rest, are largely the same as they were in the 1940s, but we can do something radically different because the computers are just different. And so those hardware constraints do, I think, manifest themselves. And again, I think for the particular sort of case of the spreadsheet, for me as an end user, and indeed for anybody who doesn't have access to the source code, Excel is not particularly malleable. But it may be changed, right? It may be changed in future versions for sure. But I'm not sure how much that really matters for the specific people.
Isn't there a social characteristic then that someone's making a decision for me, or perhaps without my participation, saying, okay, this is what a spreadsheet is, and I'm going to try to sell it that way,
right.
Then.
Yeah.
And see if there's a market for this version of a spreadsheet that doesn't have certain capabilities but has other capabilities, either of which I could have written into the original design.
Yeah, for sure. No, for sure. So you're absolutely right that different design decisions could have been made. So how do these things evolve? They evolve around a sort of like, emerging consensus around what it is that we want these things to be able to do, around the, the competitive process by which we sort of like, try to make my spreadsheet look like your spreadsheet and so forth. Or the disruptive process by which we attempt to build something that's going to look radically different and change people's imaginations. However, and it's there are different kinds of properties are more or less amenable to that. I mean, yes, you could build anything, but for instance, working with non-contiguous selections or non-rectangular selections would just start to get a whole lot more complicated and is constrained by a whole bunch of other kinds of things that, yes, you could design your way around them, but it's going to be a kind of a mess, and it's not going to be compatible with other parts of the system. So I think some of those are more constraining than others. And the sorting by color is a relatively trivial one, but a whole bunch of other things are certainly encoded in there in ways that are not trivially available to sort of reconsideration within that paradigm.
Hiya, thank you for an amazing talk. Really enjoyed it. Got a lot of great ideas. And I had lots of stuff I wanted to ask you, but I'm going to try and stick to one. I was really struck by the dimensions of the materialities you've been considering and arguing for the visibility of. And I wonder if there are implications of your research for those sectors that are working in digital stewardship, things like digital preservation and digital curation, things like that. And I wonder if maybe the work could be an interesting interdisciplinary project, possibly bringing in archive community, material culture community for those questions.
Yeah, I think that's great. You're absolutely, yes, there are all sorts of parts of that. Actually, one of the case studies the book explores is emulation, building software systems that emulate other sort of software systems, which is frequently done for archival purposes or to be able to sort of like, so that you can re-encounter old Apple II games or whatever else. And it's a strategy that people have followed in there. And a lot of this is, I'm always fascinated by the notion of sort of digital preservation, the way it gets sort of, animated, given that we literally could not have any digital files that are older than 70 years, right? You just couldn't. It's an impossibility. And even the difficulty that we sort of have ourselves. So yes, that really does sort of begin to matter. The case of sort of emulation and that question of how we make decisions about what it is we're trying to preserve and what are ephemera that don't matter, some sort of like, comes up a lot. And again, I think you can look at those sort of like, encounters with the computer system that that go beyond what sort of interactivity normally begins to sort of encode. I had this example I always remember that when I was first working for Xerox and I was using these like list machines, and I discovered that I got much more frustrated and was much less productive when I was listening to music. And that surprised me. And then I realized that what was happening was I could no longer hear the disk. And in the Lisp systems, they page a lot, and it was actually really problematic. And I had learned how to like cue my mouse clicks to when the disk was idle, so that I knew that the computer would respond to me. And so the solution to this was when I listened to music, I actually put my foot against the disk, and I could feel it, and so suddenly I could do this again. But I'm kind of intrigued as like those things that disappear out of, again, our notion of what it is to preserve and capture aspects of that kind of experience. I have, by the way, since you're talking about this stuff, I have one other example. I can't remember. It was in the book once, and I got rid of it. But it's a great. I just like to tell the story. So when I was a system administrator in Edinburgh many years ago, I was system administrator for a research group doing linguistics, and we got a new corpus of documents on a tape. And they wanted me to like load it up. So I took it to my computer and loaded up the tape, and bloop, nothing. I'm just not getting anything out of this tape. Okay. So I go across to the other side of the machine room to somebody else's fax, and I load it up on theirs, and it's like, bloop, nothing at all. It's like, huh. So I take it down to the local computer center, and the University Computer Center, and we try it on a couple of other tape drives, and like nothing can read this tape. And eventually somebody says, you should take it up to Bob and let him eyeball it. And I'm like, why would anyone eyeball a magnetic tape, right? It's like plastic metal oxide on it. We take it to Bob. He pulls out a little thing like this. It's got a name, actually. Maybe somebody knows. It's like it's basically two pieces of glass with iron filings and suspension in the middle, a little ring. And he writes out the tape, puts it on a piece of paper. And he like goes up and down with this ring, taps on it, and he like makes some notes on the paper. Pulls out a ruler, measures them, and what he's found is the inter-record gaps. And he can measure exactly how long a record is in centimeters, or actually at this point inches. And he goes, that's your problem. This is an 800 bit per inch tape. Only the ICL tape drive will read this. So again, it's just one of these like confronting the materialities of information in particularly that kind of way, where actually in this case the physical object itself could not reveal itself to me, but it could reveal itself bizarrely to Bob eyeballing it. I don't know what to do with that example, but I like that example. So.
I guess just going back to your more general or basic discussion of materialities and even just the potter's clay, and talking about, I guess, the material engagement and properties of the clay pushing back, essentially. I guess my question is, whether in your book you sort of start looking into the material agency then of, I guess, the digital, because I'm familiar with material agency, obviously heavily relying on sort of the non-human-y agency that people aren't re-looking at, but to be honest, trying to think of material agency in a digital world, I'm intrigued, but I'm not quite sure where that goes. Mm-hmm. So do you do you cover it more in the book, or do you think you're not dealing with the material agency in that way, or?
I don't really talk about that in the book, but I think it's interesting to explore, and we're sort of talking about it for a minute. So certainly that issue of things pushing back is sort of like central to the sort of like part of the sort of central intuition here. The examples, most of the examples that I work through, and especially anything that I want to sort of try to get at ethnographically, is lives in a world of much more distributed agency than that sort of potter's clay example would offer. And it goes actually slightly to these kinds of cases before of like, is a spreadsheet reprogrammable? And the answer is like, well, sort of yes and sort of no, right? Yes, it is, but not necessarily by me, and it's still got to be compatible with the other parts of my computer system, and it's got to sort of work in a way that I can sort of send things around and the rest of it. And so I'm hemmed in by constraints of all sorts, some of which are constraints in the digital and some of which are constraints in the social and the cultural. And the actual sort of like the location, so you are talking about a much more distributed form of agency that's partially material and partially not.
But, I'm thinking also in terms of, I agree that the potter's clay is sort of, the vicinity is sort of very immediate, but also in terms of sort of, extended cognition in a way that deals with materiality in a more distributed aspect.
Right.
Like it does, so you're looking at inaction, like cognitive inaction, and that the mutual creation of worlds and perceptions through the material agency in an environment. So it's not just the immediate object that's pushing against you. It's also the material agency sort of in the situation. It's very situated.
Right. Yes. No. Absolutely. And so and I sort of like at least with when talking about the case of sort of number systems. It's sort of like, is something I take from the sort of distributed cognition, external cognition people a little bit. It's when we start to talk, as we do, for instance, in that spreadsheet example, and as I do a little bit when talking about databases as well, about sort of like, how it is that particular kind of representations and representational practices are then embodied in larger social systems and in processes particularly, then you're sort of very much sort of playing in that space. But it's not a perspective that I especially nor explicitly explore in this book. It's a good. Well, no, it's a good. I mean, it's a good question. I'm trying to think now about why. So let me tell you. Here's the story of the book. In some sense, is that I did start the project by trying to sort of think it through from the sort of like the theory side, and I wasn't really getting anywhere. I'd had an unpleasant 18 months, and so then I started instead working through the cases to try to see how it was that at particular sites I could find some value in this, or find whether there was any value in this approach and what kind of purchase it gave me on those cases. Now, those cases have come from different kinds of places, and as I said, they're engaged with different kinds of other audiences, and some of them are within aspects of my own work or in collaborations with other people. And so a lot of the way that this thing has been sort of like, driven responds to the specifics of different kinds of cases. And so, I mean, I think you're putting your finger on something that's important, and it happens not to be in there, but not really particularly by design and sort of by choice, but sort of, as a historical artifact of how it is that the program has developed, which just means I should do it for the next book.
The message I think I'm supposed to take away is that a metaphor, you didn't mention the metaphor of the cloud, but the cloud might have been the sort of the anti-metaphor for you, in the sense that it's the one that causes people to think that their computations are going on in some metaphysical space up there. And as you remind us, they're actually going on in one Wiltshire. This is very important. But having reminded us of this, because we've got away from it, I just wonder what follows. I mean, you gave this excellent example of the tape, so many bits per inch tape, which was a form of old concreteness. I go back further to when on an ICL machine you had the opening command had to be set by a bank of switches on the front, which corresponded to the internal command to start the thing rolling. So what I mean is, in those days, God save us, we ever go back, you couldn't forget the materiality. It was right in front of you as your fingers switched, however many switches down it was. So, but once we've been reminded that we've got away from that reality, and you tell us it really is still real, what follows?
Nearly provided me an opening to some. Oh, never mind. I just going to pull out some things. Here's what's important for me. So I'm not simply concerned with reminding people of the again, what I sometimes call the brute materiality, the fact that it's there. It's good to remind people of that. That's not my point. My point is to be able to try to find a level of analysis that is useful, that proceeds from that understanding. So the question is, on what level do we want to try to pull that out? So a lot of the work I've been doing is in conversation with people in software studies. And in software studies, I would say people have been engaged in a long-term project to try to determine at what level do you want to carry through that sort of materialist account. So the platform studies work that people like Nick Montford and Ian Bogost are best known for is a response to exactly those kinds of questions, but of a very a violently concrete nature, right? Their book Racing the Beam on the Atari VCS is more detailed documentation on how to program the Atari VCS than Atari ever provided to its developers. But I find that really interesting, but I'm not sure that I actually, in pretty much the way you suggest, it provides me any way to proceed, except by putting down the Atari VCS and picking up the next thing and doing the same and so forth. I'm wanting to try to find, and then at the same time, there is this sort of super high-level stuff in software studies that analyzes, poems written in Perl and tries to tell me something about the nature of contemporary textuality. I'm not sure I find that terribly compelling or useful either. I'm trying to find a way that connects an understanding of the material and the digital with organizational ethnography, and that's something that helps me see how it is that those things might mutually shape each other, or with sort of like questions around internet governance and things, but sort of that, you know, that ties it to sort of to what's going on representationally. So the argument is not simply that that's what I was calling the sort of brute materiality. I want to know, how is it material? What kinds of materialities are on offer? And what does that mean for then how we might want to think about guiding or shaping design processes, and guiding and shaping those processes of sort of technology adoption, recognizing that that things are material in different ways, and that there might be choices we can make about how it was that the digital is to be materialized for us. There's one over there.
You briefly mentioned ephemera, and I'm really interested in this move from brute materiality to multiple materialities and how that relates to our conception of ephemera.
Yeah, I'm really interested in that too. Do I have an answer? I mean, I think so. The thing that's important for me about the multiple materialities is that there are multiple parallel materialities, right? I mean, it's like, you know, that something has a certain kind of granularity and a certain kind of heft and a certain kind of weight and a certain kind of fragility all at the same time, but different of those things, as I say, sort of matter to us at different moments. One of the, so I was, you know, talking about the ephemerality a little bit in the context, for instance, of emulation, and one of the things I sort of use emulation to do is to think about sort of rematerializing things digitally. So not sort of the production of the virtual object, but again, a sort of process at which we've had to make some choices about how we want to recreate a sort of a material experience. I think the real important thing about I'm thinking about ephemera important place it might take us is in thinking about the temporalities at which these things operate, and trying again to. Okay, I will go down this path after all. So, how much time do we have? So in the one of the things I've been doing lately, just for my own amusement, although it's now turned into an intellectual project, because one of the delights of academic life is that one actually can have no separation between hobbies and intellectual projects, is I started for no good reason other than I wanted to stop reading newspaper articles about Donald Trump for a while, building like a 1970s era 6502 based microcomputer of my own to like a little nostalgic trip. Here's the thing with this computer when I built it, it's like it runs 50,000 times slower than my laptop. And yet, on my laptop, I never have to think about things on the order of microseconds. Whereas when I plug my oscilloscope in to like try to figure out why it is that the processor is not properly latching things onto the address bus, I do have to like care about things. And so of that sort. And so I'm kind of fascinated by the multiple sort of layered and complicated texture of temporalities in the digital that radically, I think, resists this this standard notion we have of the ever quickening pace of interaction and how everything used to be so slow and now is so fast. And so I think one of the things that a sort of materialist account can do is it can help us to sort of like, help to steer how we think about the level at which we're engaged with the digital and with digitality, in which things become transient or ephemeral or permanent or stable, and sort of like on multiple different kinds of levels at once. It's not really a terribly helpful answer, but.
Last question.
Well, thanks for your talk. Right now we're witnessing the first wave of adoption of these kind of new devices, these voice-first interfaces like Amazon Alexa, Google Home, Siri, which are primarily, audio-oriented and which kind of have some kind of social personification there. I was curious, in the lens of the way you think about materiality, is there anything that you think comes to the foreground looking at those devices through this lens that other people might not immediately see?
let's see. A couple of things. One, I am struck by the phrase of voice-first interfaces just instantly started me thinking: are they really, or are they text-based interfaces to which you talk? It's like they're transcript-based interfaces rather than voice-based interfaces in some sense, right? I think about all the sort of the rich nuance that the voice carries, the way that people talk, the way that conversation proceeds, all the things that go beyond the transcript that ends up on the page. And yet these are actually places where I know when I talk to Siri, I have to make sure I know how to talk to Siri and make sure I know what kinds of things Siri will hear me as having said. I think it's also interesting that the most recent version of iOS allows you to type at Siri as well, right? So you don't have to talk to it. The other thing it naturally sort of brings up and is the design of the spaces into which those applications or those objects are being deployed, and their expectations about what happens in those spaces and how it happens and when it happens and who does it, and what it means to what is. Given that there are already people who have had to think about how they want to reconfigure their houses to allow the Wi-Fi signal to get around better, you begin to wonder what it means to be able to configure a space so that those objects can hear you properly. But I do think it's useful for us to imagine different ways of thinking about what the voice might be as an interaction modality there. I don't know. Slightly materialist. Slightly.
Speaking of interaction modalities, let's go make some wine ephemeral. Thank you. Let's give our
Thank you.